So now we have talked about 4 microfluidic platforms that you can find commercially. The PDMS platform, the lab on a CD, electrowetting based platform, and think specifically of the DNA platform here. And the 4th one is the droplet platform. So let's do 2 quiz questions and comparing these platforms with each other. And my first question is about how well are these platforms in controlling the specific position of one specific sample volume in the system. So that's my first question. Sort the microfluidic platforms in order of how good they are in sample controllability. And I want you to, those 4 platforms, to put them either, you say they're low to medium good in sample controllability, or they are rather good, or they are very good. And I want you to kind of rank them, put them all 4 somewhere on this scale. The second quiz question is again about the 4 systems, and now I want you to compare them in terms of how good they are in doing a very high amount of parallel equal tests. So how good are they in parallelization? And I mean in having an extremely high amount of individual sample volumes that can be handled simultaneously and doing the same thing. So are they low to medium good, or rather medium to high good, or very high, very good? So let's first look at sample controllability. Let's first consider the PDMS system and the electrowetting system, because they are somehow comparable. In both cases, you can make small compartments of liquids and you can steer them in a direction you want to. In a PDMS system, you're going to do that by pneumatic valving, by moving things from left to right or up to bottom. You can do that in many directions. And in electrowetting, you can do exactly the same, but just control, instead of doing it pneumatically, as in PDMS, you're going to do it electrostatically. But you basically do the same thing. But these both systems are excellent in making, in exactly placing particular amount of volume in a certain position, because you can put it there just by pumping and valving exactly the position where you want it. And you can select one part of liquid and move it to another part and station it there. In terms of lab on CD, that's going to be much more difficult. There you add samples in the middle, and then you kind of compartmentalize them, but you can only move from the center to the outside. So is this a center of my disk? They always go from the center to the outside. They're going to step, 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 and that's basically what you can do. There are some integrated pumping mechanisms that can pump things back, but I don't want to touch that right now. So, but basically, you can do some control because you have this hydrophobic barrier, so you can like position, but then once you're at the outside, basically you're stuck. That's how far you can do. So there's only a medium amount of control possible there. And when it comes to the droplet based, there you have no control. You just send in your droplets one by one, and they just flow 10,000 per second after each other, and they just have to flow. They have to go with the flow, and you cannot. There is sorting possible dielectrophoretically, but still you can only do, for example, one channel to the other, and they just have to keep on flowing. So there you have a rather low control of exactly which droplet is in what position at what time. But on the other hand, if you then look at the amount of parallelization, the droplet system is of course the big winner there, because if you do 10,000 droplets per second, I mean, in an hour you can make, what is that? 30 million reactions, not individual, but 30 million reactions in different droplets. That's extremely high amount. So that's very good. In terms of a lab on a CD, we've seen the example of the CD where you had 96 different wells along the radius. The amount of compartmentalization there is limited, because all these little channels have to lay one next to the other in a radial fashion. So maybe you can have up to 100, maybe 200, press 200 little channels next to each other. That might be possible, but it's more difficult to do even more. So there, the amount of parallelization is limited to maybe 100 or so. It's medium low. And then when it comes to the electrowetting on dielectric and to the PDMS, again, they are comparable, because now we have the entire area of a chip, and basically you can cut that in little parts of, say, 200 by 200 micrometer, if that is the size of your droplets or of your valves, and you're going to be able to compartmentalize your entire liquid in little 200 by 200 micrometer little compartments over the entire area. So the entire area can be used for compartmentalization, and it's a medium-high kind of amount of parallelization you can do there.